factoring trinomials. So trinomials mean that there are three terms. So for example, this could be a trinomial that you're given. And the directions are just to factor. So we're not solving for x or anything like that. We just want to factor. And factor means we want to go back to the two parentheses that in the last section we just practiced foiling. So what I want to do is think, okay, if I want to go backwards, so I want two parentheses, I have to think what times what is x squared that would go here and here. And you probably know the only thing that will be x squared is x times x, so that's good. Now you have to think what times what will equal 15. And it could be 15 times 1, it could be 5 times 3, and of course the order of those could change too. So this is what your head has to process. You have to put here something times something that equals 15. But when you add your outside times your outside to your inside plus your inside, so they're going to multiply and they're going to multiply. And then you're going to add them. They have to add up to 8. So looking at those, you can probably see that, aha, 5 and 3 will add up to 8. So I know I'm going to put my 5 there and my 3 there. And then this is kind of nice. If these are both plus, you automatically know these are both plus too. Because a positive times a positive will equal a positive 15. And then a positive 5x plus a positive 3x will add up to your 8x in the middle. So that's your solution right there. You've just factored, and that's your answer. Let's try another one. What if I have x squared minus 10x plus 24? So once again, I know I need two binomials, and I know that the only thing that can be x squared is x times x. Now let's list what could possibly be 24. We know that we could have 8 and 3, we could have 6 and 4. So there's a lot of possibilities that equal 24. But we know that they have to add up to negative 10. Now we want to think about the signs for a second. For something times something to be positive, they either both need to be plus or they both need to be minus. So if they're two negatives, it will equal a positive 24. But if there were two positives, that would equal 24, but that would never add up to a negative. So they indicate that the signs have to be the same for this to be positive, and they have to be negative to add up to negative 10. So I'm going to put a negative and a negative there right off the bat. And that's helpful because now I can see that, okay, I'm going to be combining them. I'm going to be adding these. And 24 and 1 are going to be 25. 12 and 1, oops, I'm sorry, that should have been 12 and 2. 12 and 2, they would have a difference of 10, but since I know they're going to have the same sign, I know that won't work because they would be 14. 8 and 3 would be 11. Ah, it must be 6 and 4. So if I put negative 6 there, inside times the inside is negative 6x, out to negative 10x, and that's what's in our middle. Let's go a step further. Let's say that I have, let's say that I have 3x squared plus 13x plus 4. Now, once again, I'm just going to two binomials. So, now here's what's new. In the ones we've done previously, we didn't have a coefficient in front of x squared. This one has a coefficient in front of x squared. But the good thing about 3 is that the only thing that can be 3 is 3 times 1. So it's got to be 3x times 1x. Now I could flip the order of those, but I know I have a 3x times an x to equal x. Now once again I have to think what times what is 4. And I know it could be 4 times 1, it could be 2 times 2. Now the order matters because whatever I put right here will be times 3. So 4 times 1 and 1 times 4 are different. So now we have to think, whatever I put right here, I'm going to put 4, 1, 2, 2, 1, 4 here and here. And whatever you put right here won't change because it's times 1. But whatever you put right here is going to be times 3 before you add it to the inside times the inside. So now I want it to add up to 13, so I want it to be pretty big. You can see if you put 2 and 2 there, you would have 2x plus 6x, but that's not going to add up to 13. So I'm going to try the big number. I'm going to put 4 there, and I'm going to put 1 there. I know that my signs are both positive, so I can put those in. And then look, I have 4x times 3x is 12x. 1 times x, is 1x, and that's 4 times 3x is 12x. And look, they add up to 13x, my middle. So I know that's correctly factored. Now, this is called trial and error, and this is a good method, and I'll be honest with you, this is the only method I knew through 4 years of college. This is how I did it every time. I just did it by trial and error. However, if it gets complicated, for example, let's pretend that let's give you this problem. Well, now, if you wanted to go straight to your parentheses, you could have 2 times 3, 6 times 1, 1 times 6, and this one too. 2 times 3, 3 times 6, 3 times 2, 6 times 1. So in other words, you have a whole bunch of possibilities for your last times your last and your first times your first, and they've got to add up to 13x by grouping that you might like. And some students like it, and some students just like trial and error like we did up there. So whichever one you like. It might come in handy when you have a big number here and here, so there's a lot of possibilities. This is how you factor by grouping. Every single time you take the coefficient of x squared times the constant. So I'm going to go 6 times 6 in this case. And let's write down these steps. So I have the coefficient of x squared times the constant. And then I'm going to factor, so that's 36. And then I'm going to start factoring 36 into everything I can think of that's 36. So 36 times 1, 12 times 3, 9 times 4, 6 times 6, whatever you can think of. So we're going to factor that number. And you just factor it as many times as you can. Which one of those will add up or subtract to be 13x? And since 6 was positive and parenthesis, they will both be positive. And that means that I'm going to be adding them to be 13x. So this is positive, so these are the same. They're going to have the same. Is it 36 and 1? No, that would be 37. 12 and 3? No, that would be 15. 9 and 4? Aha! That is my pair that works. So the next thing you do after you factor them is pick the pair that adds up to your middle term. Adds up or subtracts to be the middle term. 9 and 4. So now I'm going to come up here to my equation, and instead of writing 13, I'm going to write 9 and 4. And guess what? The order doesn't even matter. I could do 9 and 4 or 4 and 9. So let's say I'll just leave it how it is, and I will write 9x plus 4x. So I use 9 and 4 and I replace 13. Now look, 9 and 4 is 13. So I haven't changed my problem. I just wrote it differently. Now I'm going to get rid of that because it's kind of in our way. But now what I'm going to do is factor by grouping. You just made a problem that will always work if you factor by grouping. So what's the biggest thing you can pull out of that pair? A 3 and an x. And we're left with 2x plus 3. What's the biggest thing you can pull out of that factor? A 2. And we're left with 2x plus 3. Something's wrong. So I have a common part of both terms that I can, if I divide it, I'm left with 3x here. If I divide it, I'm left with 2, or factor it, I'm left with 2 there. So you just factored this polynomial. This trinomial factors into these two binomials. Alright, let's try another one. How about this one? Alright, so once again I begin by multiplying. Let's put after that, replace middle term and then factor by grouping, and you're done. Okay, so in our new problem, I'm going to take 12 times 2, and I'm just going to start factoring that into everything I can think of that equals 24. And then I look at those pairs and find one. In this case, they're both positive. These are positive, this is positive, which means these have to be the same. So they have to add up to 11. And I see the 8 and 3 will add up to 11. So 3x plus 2. So there's my 8 and my 3, and I have those there instead of that 11. So I haven't changed the problem. This and this are equivalent expressions. But now I can factor by grouping. So I group those two and those two. So right here I can take a 4, can't I, out of both of those, and an x, leaving me 3x plus 2. And by the way, if you flip-flop the 3x and the 8x, look, this is a good one for you to see an example of. What I have right here is exactly what I need, and I can't factor anything out. So just think of putting a 1 there. You can imagine an imaginary 1, and they wouldn't write anything because we know if nothing's there, it's like a 1. But now it looks like a typical problem. And now you've got that common factor, and then you're left with your 4x plus 1. Okay? So this trinomial factors to this. And by the way, if you ever see this, that is equivalent. Order, multiplication, order is optional. It's commutative. It can change. So you're good with this or this. Well, we'll factor now for forever in math. Everything requires factoring. So, I don't know how to turn my phone off. So make sure that you practice this section thoroughly. Really get good at factoring because it will not go away. It will be in all the math we do for the rest of the semester.